All right, good morning, good afternoon, good evening. Thank you all for joining us for our first blockchain webinar in a series. This is Blockchain 101. Glad to have you all on listening in today. You should stay and remain muted. If you would like to ask a question, you can do so by pulling up the chat window, which is available at the bottom or the top of your screen, depending on the Zoom client that you are using. This recording will be available on our website, and you can share this with colleagues or keep a record of it for yourself by referring them to our website. Also on our website, recently published, is the Blockchain for Hospitality white paper, which was produced by the HTNG Blockchain Workgroup. And the chairs of that workgroup were Doug Rice and Andrew Sanders, who I'm happy to have presenting today the Blockchain 101 webinar. So, gentlemen, would you like to introduce yourselves?
Certainly, thank you, Armand. My name is Andrew Sanders of DataArt, and I'll be helping today with Doug Rice of Hospitality Technology Network, present, as Armand said, on the topic of Blockchain 101 for Hospitality, which will serve as an introduction to the series and aimed at a management level for those with an interest in blockchain and the hospitality travel sector. Thank you. So HTNG is a trade association that fosters collaboration between hospitality professionals and technology providers. It saw the need to engage in the topic of blockchain and established a work group on the subject at the end of 2017. If you could hit enter, please. Thank you. So the work group collaborated and decided that to be educationally based, principally because it felt that there was a severe vacuum and lack of knowledge on the interest in the area of blockchain and how blockchain may impact travel and hospitality. So the work group, which consisted of many people from the industry, produced an educationally biased white paper on the basics and fundamentals, plus some details. So it was targeted at both management and an executive level. If you can hit enter, please. Thank you. We also decided to try to be a useful resource where people could go to for information on active projects, because we felt that there was a gap or a gulf of knowledge in that area. So we've established a project registry, which will also be available through htng.org. And we're also converting the key components or sections of that white paper into the form of digital assets, such as this webinar, that will be used in the form of a series of discussions. So really to try and make the lifespan as long as possible, but probably not that long considering that the state of blockchain is in its relative infancy and rapid development. So I'll pass over to Doug to introduce the topic in more detail, and I will be back later on some more details. Thank you.
Thanks, Andrew. Good morning, everyone. So we'll start off with some history and rationale about blockchain. If we talk about distributed ledgers, which is really the technology behind blockchain, those actually predate modern computing. You can find examples of that go back to the Roman years, even in the pre-Christian era. The technologies for distributed ledger, however, started to emerge really in the late 1900s. And a cryptocurrency model that exploited and improved the digital ledger technology was really first conceptualized in its current form in 2008 by a person or group known as Satoshi Nakamoto. It's not really known whether this is a single person or a group of people. It's a complete pseudonym. The technology later became commonly known as blockchain, and Nakamoto established the Bitcoin cryptocurrency based on the blockchain model. So if we look at what basic problems blockchain solves, and I'm just going to highlight a couple of the most important ones here, it creates a guaranteed and trusted record of data or assets of value. That can be money, it can be property deeds, titles, patents, intellectual property, identification, music, almost any digital transaction or digital asset. It also allows two parties to immediately establish a trusted relationship without using a middleman. And that this could involve things that are currently handled by banks, notary publics, title companies, credit agencies, even the Department of Motor Vehicles. Blockchain is often confused with Bitcoin, and I'm going to kind of set the stage here by saying we should not equate the two. If you look at the graph there from 2010 to 2017, you might think that's the price of Bitcoin, maybe through late last year. But in fact, it's really the number of Google searches on the word blockchain. And you noticed it was basically zero until 2013 or so. That's really when the name started to come into common use, even though it is the technology that Bitcoin was based on, and Bitcoin was founded in 2008. Blockchain also isn't any other cryptocurrency. It's not Ethereum, it's not Ripple, it's not Litecoin. It does enable them all, but as we talk about it today, we're going to really focus on things that have relatively little to do with the cryptocurrency side of blockchain. This next slide should help you think about what blockchain is. It's simply a different type of database technology. In the 50s, we had flat files. They served computer science pretty well in its early days, and they're still around today. In the 70s, we had relational databases appear. In the 90s, we had new technology database such as NoSQL. And now in the past 10 years, we've seen the emergence of blockchain and other forms of digital distributed ledgers. You've all seen the Gartner hype cycle, I'm sure, where disruptive technologies go through a sequence, usually something like this. Initially, there's a lot of hype. Eventually, reality starts to set in, and we head into the trough of disillusionment. And at that point, a lot of people think the technology was a total bust. Then over some period of time, we start to see real value being built out of that new technology. And we enter the slope of enlightenment, and eventually it kind of plateaus off. So where is blockchain on this? Well, I think arguably the peak of the cryptocurrency craze was probably reached around the end of 2017. And I would argue that we're somewhere between the peak and the trough at this point. I think within the coming years, we should start to see some real value coming out of the technology based on some things that are being built now. And we'll talk a little bit about some of those later in the session. So hopefully this session is going to help you see how that can happen. So blockchains come in a lot of varieties, but they all share certain properties. First of all, they are immutable, which means basically that they cannot be changed. Once it's been written, if it's changed, it's evident to anybody who can see the blockchain that it has been changed, and they will know that it's been tampered with. It is distributed. That means that it runs on multiple nodes. It's not sitting on a single computer someplace or even a single computer in a backup. It's often running on tens or hundreds or even thousands of computers that can be spread around the world. It is decentralized. That means that the nodes are peers. There's no single controlling node in most cases. Certainly in a pure public blockchain, as we'll talk about in a while, there is no controlling node whatsoever. It is cryptographic. And what that means basically is that the blocks are cryptographically linked in a way that you can tell that they are securely maintained in the same fashion in which they were created, and they have not been altered. And it's auditable, meaning that anyone with access to the chain, which may be the public, can actually look and see the exact history of the transaction. You can't go and change a transaction. You can only add new ones, and those new ones may modify the end result, but they don't modify the original transactions. So why is it called blockchain? Well, if you look at the structure, it really is just a chain of blocks. You have data in the yellow areas where it says block 4 transactions, for example. It is linked to the prior blocks with a cryptographic hash that ensures that there's integrity. And then new blocks are added that are continually linked. So you can see this chain and you can verify cryptographically that it has not been altered. You hear a lot of buzzwords in the blockchain world. This slide is designed to help you organize just a few of them. And these are all examples of blockchain ecosystems. These are blockchain-based environments that are internally consistent, but based on different design variations or principles. Most blockchain projects that you hear about are going to choose to work within one of these ecosystems. Some of them do interoperate to a degree, and you link different blockchains that are made in different ecosystems. But generally speaking, when you're developing, you're going to be working just in one. This is not an exhaustive list, but these are 4 areas where there's really been the most discussion of use of blockchain in hospitality. I'm just going to call your attention to them very briefly now, so that as we dive down a bit into the blockchain technologies in the next several slides, we can ground the discussion in specific relevant applications, and then Andrew will come back in a little while and take you through some of the details of those. So there are really 3 types of blockchain: public, private, and consortium. We're going to talk about each of these in turn. Not everybody agrees that consortium is a totally separate type of blockchain. It gets into semantics. We're going to treat it as one, but there are there is some overlap, and some people might argue differently. So if we start with the public blockchain and we look at the various aspects of a public blockchain, the first thing about it is trustless. What that means is that you do not need to have trust in the other people on the blockchain. The blockchain itself ensures the integrity of the transactions that are made. So whereas with a transfer of money, you typically will have a bank involved because the banking system is at least somewhat trusted not to screw things up. And you send money and you know that if the money doesn't get where it's supposed to get to, that you have a way to research that and the bank will generally make it right. Blockchain doesn't operate on that principle. It doesn't require trust. Anyone can create a transaction on a public blockchain. That means that you can download free code and do it yourself, and you don't need anybody's permission. You don't need to sign up. You can just get yourself some code and an address, and it's all public. You can do it without anybody's permission or sign off. Anyone can read the transactions as well. If you want to know the history of Bitcoin, you can see every transaction that has ever been made. You may not know the identities of who's sending or receiving Bitcoin, but you can tell what Bitcoin was sent. Same with any other cryptocurrency or any other blockchain transaction. The governance of a public blockchain is shared, and anyone can participate in it. Public blockchains do tend to be slow and expensive. You've probably heard that. The amount of electricity that it takes to run Bitcoin has been somewhat larger at some points than the amount of electricity it takes to run New Zealand. And as a result, it's quite expensive. And that's very true. There are changes going on in some public blockchain ecosystems that should make it less expensive over time. But it certainly is true that it is expensive and slow. It can take a significant number of minutes for a transaction to be confirmed on a blockchain. Public blockchains will have an embedded cryptocurrency. It's necessary because the concept of public blockchains requires economic incentives, and the cryptocurrency is what provides those incentives. It can also be used to exchange value, obviously. Public blockchains also have open and public APIs. One is that anybody can create transactions. You can go and find the APIs on a place like GitHub and download them and use them. Public blockchains I think quite importantly, are the only option that can fully eliminate middlemen. If you want to do a financial transaction and not have a middleman like a bank, you can do that on a public blockchain, and you cannot do it on the other types of blockchains. So if we move on to the second type of blockchain, is a private blockchain. What are the aspects of a private blockchain? Well, first of all, it works in a trusted environment. As we talked about, public blockchains not requiring trust, private blockchains need to have some trust between the parties that are putting transactions onto the blockchain. It could be that they're all in the same company. It could be that they have an existing relationship of trust with each other. But in any case, the blockchain is not going to provide the trust. Only users who are approved can create transactions on a private blockchain. So you can't just go in and modify somebody else's private blockchain. Typically, a single node is going to validate the transactions. Doesn't have to be that way, but that's usually the way it is done. A private blockchain may choose to provide some public read access. If there's a blockchain that needs to be seen by third parties, you can allow it, and that can be limited or it can be totally public. Private blockchains really don't have the same cost or performance limitations that public blockchains do. Because the consensus mechanism for approving new transactions is very simple, it's just a single node typically validating it. That doesn't take a lot of computing power, unlike a public blockchain where you may have thousands of computers vying to create the next transaction and then approve it. Private blockchains, however, do not eliminate middlemen. So if you have a middleman that you want to get rid of, this is not the right option. Cryptocurrencies may or may not exist in a private blockchain. They often are used for certain purposes, but they're not required. Private blockchains can work quite well for in-house applications. If you need that audit trail and you need a simple way to stage a complete record of all transactions where maybe there's 3 or 4 different systems that need to consult it, this is where we're seeing some blockchains being used within private companies. If we look at the centralized versus decentralized, just to differentiate public and private a little bit more, many ecosystems are built around middlemen, banks, distributors, including travel intermediaries, and many others. Unfortunately, over a time, market power tends to get concentrated and the intermediary may start to extract fees that the players view as excessive. Blockchain can replace any central point of authority with a decentralized virtual middleman. And what this does is to remove the need for trust in a central power. So if we move on to the third type of blockchain, the consortium blockchain, this is a hybrid model. It's somewhere between public and private. It's usable where trust is present. Often, and the name would suggest this, often where you have a consortium of different players within an industry that want to share information and maybe have a certain degree of trust with each other, but maybe not total trust, or maybe they don't trust that the systems that they're dealing with are totally accurate. So they want to simply have a single point where they have a record of all transactions that sit between the systems. Only the participants in the consortium can create transactions. The transactions are going to be validated by some sort of a consensus. So if you were to imagine a consortium, let's say, of loyalty programs that want to exchange miles, points, whatever, they may put together a blockchain consortium and allow these transactions to be added by anybody who's a member of the consortium. There's contractual relationships between them and they trust each other to be able to use those contracts to enforce their rights, but they still want the transactions to be validated by more than just one party. So maybe 3 or 4 or 10 of the consortium members are enough to validate. They may provide some public read access if they want to, or they may just provide read access to members of the consortium. Again, there are relatively few cost or performance limitations because it's a relatively controlled computational process that doesn't require excessive resources. And in this case, the blockchain really is the middleman. It's serving the purpose that you might have to go out and hire a company to do in legacy technology. And the consortium members themselves wield control over the rules of the consortium and how the blockchain will be governed over time. So let's talk just a little bit about the hype and reality of blockchain. You certainly see articles all the time talking about it's hype in this way, or it's fraudulent or whatever. I just want to address a few of those before we get into some of the details. The first one that you frequently hear is that blockchain, and often this is really, they're talking about Bitcoin and sometimes using the words interchangeably, is used by criminals. It absolutely is used by criminals, just like the internet is used by criminals and just like almost any other technology is used by criminals. Really, just like the highway system is used by criminals. Anything that is an infrastructure is going to be used by criminals as well as well-meaning people. So that's absolutely true, but it doesn't mean that there aren't legitimate applications as well. You hear all the time that blockchain investments, and you hear frequently about what are called initial coin offerings or ICOs, that they're often fraudulent. And that's certainly true, that are in fact fraudulent. It is a new way to make money, and it's a new way for people to essentially mint money by preying on people who are not sophisticated investors. But many blockchain projects are also undertaken by reputable, large existing companies, and they aren't externally funded at all. There's nothing fraudulent about those. They're just like any other corporate investment. And new ventures are always risky, and certainly there are many ICOs that are fraudulent, but there are also quite a few that are very legitimate and are doing some very interesting things. You hear the blockchain is too slow, and true of public blockchains, although the technology is evolving fairly rapidly, and most people believe that as this moves forward, we will see significant improvements in the speed of blockchain. And it's not true today of private or consortium blockchains. You can get them to go just about as fast as you need them to. You hear that blockchain is too expensive. And this certainly has been the case when Bitcoin transactions were costing $50 or $75 to do. That was really more than was reasonable for a lot of the applications that people would have. And that's really tied to the fact that it is too slow and too computationally intensive. And that again is where there's a lot of change going on with some of the newer technologies, and also certainly with private blockchains as well, where the cost is coming down very rapidly or is already down. And probably the last one you hear a lot is it's a fad. It's only used by sleazy companies run by millennial geeks, not by reputable companies. And certainly there's some truth to that, because some of the companies are definitely not very, well, I guess actually some of these are fairly reputable, aren't they? This is a mainstream technology at this point within the corporate world. And I think if you see some of these companies, and Andrew will give you some examples later on some of them, these are companies that are seriously investing in blockchain to solve real problems. So with that, I'm going to turn it back to Andrew to talk a little bit about what organizations are already doing.
Thank you, Doug. Terrific introduction there. So if you could just click for me. Thank you. So we know that 80% plus of major banks worldwide are already working on blockchain-related projects, and their uses include a number of things. So really, by way of example, speeding up and simplifying cross-border payments and reducing costs significantly is a big area for them. Share trading, and also their own versions of loyalty and rewards. I also want to talk about online identity management, because I think this touches upon an area of interest for many people in the audience, and travel and hospitality in particular. And we'll talk about it in a minute as well. But there are three areas that this covers. First of all, checking, the substituting of the face-to-face relationship and or checking that the person possesses the appropriate official government documentation. Authentication, in other words, proving who you are each time you log in. And then authorization, in other words, confirming that you're allowed to do what you want to do. These are all areas that are being worked on right now, particularly in the areas of banks. Thank you. So Barclays Bank, about a year ago, announced they were successfully able to complete the certain letters of credit transactions from days to hours, from about 7 to 10 days, in fact, to just a number of hours. And the government of the United Arab Emirates wants all, if you just hit and click, thank you, wants all visa applications, bill payments, and license renewals, which will number over 100 million documents a year, to be transacted in some way, shape, or form digitally and over blockchain technologies over the next 2.5 years. NASDAQ is also already using blockchain for record keeping within the areas of management and of private market securities. And Walmart uses the blockchain technology for provenance of items transacted, shipped around the world, so they can trace every ingredient and trace every item from where it was originated. So in the event of a food scare, they can backtrack to find out which farm a mango came from, for example. Thank you. So I'd like to touch upon some of the use cases that are currently being launched, or currently being worked on, or that we believe are ripe for use in a blockchain world. Each of these following examples will have its own webinar in coming weeks, so I'm just going to be summarizing at a high level here. We actually have a slide at the very end with the timetable of the expected schedule for those webinars coming out. Doug has already highlighted the differentiators between public, private, and consortium type of blockchains. And as you will see, each of them have their own specific applicability in the various use cases. So in the areas of distribution, there's currently a multitude of disparate private databases that need to be synced constantly, all sorts of hotel property management system, booking central reservation systems, and OTAs, all needing accurate and up-to-date data, typically connected, being connected via channel management and distribution systems and other switches. The end result is that the asset owner, in other words, in hotel world, the owner of the bedroom, can often end up paying commissions and fees to multiple third parties. And companies and organizations being set up to help facilitate the openness of data, believing that it can be made available more democratically, and therefore disrupt, although probably not eliminate, the role of the traditional middlemen. If you would please click, thank you. So some new solutions are developing blockchain platforms to facilitate buyer-direct connections for booking and payments. And the method between the public and consortium and private each can apply. We can click through this, please. Thank you. Now on to the next. We can click on to the next one, please. So in the case of loyalty, there are companies that are being set up that have launched connection services between cooperating programs to help facilitate the earning and the usage of points. Currently, they can be on a private or consortium platform, and possibly public in the future, limited right now for cost reasons primarily. Please click through, thank you. Yes, thank you. So payments. Currently, this is B2B. It's right now it's not practical for B2C for a variety of reasons. And it's practical today in a public blockchain environment. And as Doug mentioned earlier, the public blockchain is open in terms of participation. So access to the data is public, and therefore trust is typically an issue. And one more, please. Thank you. So the areas of identity management, I mentioned in the earlier slide about what banks and so on, financial institutions are using for identity management, and also has great applicability for travel and hospitality. It can be operated on a public or consortium-based blockchain. And it covers the three areas that I mentioned earlier. That's checking an identity, authentication, and authorizing the validity of a transaction. So guests and travelers control their own personal information, and also they can grant permissions to whoever they like as their own trusted third parties. And we think that this topic is perhaps one of the most exciting from a consumer point of view, as it offers the potential for making big improvements in frictionless travel and reducing the need for some touch points on a traveler's journey. For example, the areas of reservations, check-in, passport, visa control, for example, security, boarding, baggage handling, and once the traveler is at the destination, hotel check-in and mobile key. All of these are being worked on right now. And this leads on to, thank you, the World Economic Forum, which is a major initiative pulled together by Accenture with input at the senior level by governments, airlines, and major hotel companies, including Marriott, Hilton, and Accor, plus, interestingly, organizations like Interpol, Amadeus, Visa, Concur, Google, and many others. And here, the concept here is that frictionless travel, which many people in the audience here will be encouraging and be looking forward to, can really be helped by this type of concept where a digital identity is put on a blockchain controlled by the traveler or the guest in many ways, so that they have access to their own information, but also control who in their travel journey has access to that information. So if we could slip to the next slide, please. Thank you. So HTNG is very grateful that the work group that it established had a number of volunteers to take on the work of producing webinars, as well as contributing the content of the white paper that I encourage everybody to download and take a look at. And this being the first of several, will be followed up in subsequent weeks by more detailed more detailed webinars on the areas of use cases, loyalty distribution, and in the new year at some point, a little bit too far to give precise dates, more details on revenue management, identity management in a lot more detail, how to build a blockchain, which is really quite technical, and then an issue that we found to be quite complex in the course of when we were writing the white paper, and that's governance and regulatory issues, because this is such an emerging technology. So that all being said, I think we have time available to pose questions, and Armand, I believe you were going to moderate this part of the session.
Great. So thank you, Andrew and Doug. Really appreciate you sharing those insights. As I mentioned at the top of the call, and for those of you who joined us halfway through the webinar or after we introduced, you can submit questions by using the chat feature in the Zoom client. You can find that depending on the version of the Zoom client you're using. You can find that at the bottom or the top of your screen, and you can submit those questions here. We'll give it a few minutes to see if we have any questions. We don't have any at this time. And while you all are thinking of your brilliant questions to ask, there is no dumb question though. I'll ask one that hopefully is not dumb. Doug, you were mentioning private blockchains and the fact that they are not a way to eliminate middlemen. Can you elaborate on that a little bit? Why does a private blockchain still require a middleman?
A private blockchain doesn't depend on a consensus mechanism to create new transactions. The consensus mechanism is really what differentiates public from private. Consensus mechanism, and if we take Bitcoin or Ethereum blockchains as an example, it's all of the nodes of the miners who are running computers and trying to make money by creating new transactions. It is their work and their consensus that a new block is legitimate that creates the trust within the system. It's basically within the crypto economic way that these blockchains are constructed, it's essentially impossible or practically impossible for somebody to create a false transaction and then to have that transaction get propagated by the group. In a private blockchain, you don't have that issue. It's typically controlled by one company, and there's just not a need for trust. So there's not a mechanism that's needed that requires the kind of cost and computational power that the consensus mechanism of, say, Ethereum or Bitcoin needs in order to create a transaction that nobody's going to question. But the consequence of that is that you have to trust whoever's creating the transactions to do it accurately.
Great, thanks for that answer, Doug. We did get one other question came in from Cynthia. He was wondering how you can bring multiple stakeholders on a blockchain network. Specifically in the case of, say, supply chain environment. What kind of data security measures will apply or imply?
Andrew, you want to do that? You want me to take it?
You can take it, Doug. Thanks.
Okay. That's going to depend on how you design the blockchain. If you're doing supply chain that's completely open and it needs to be a public because you have no trust, then the security is entirely built into the blockchain itself and the way transactions get added to the blockchain. A more common situation in that particular use case might be that you have a consortium where you have a number of suppliers and potentially a number of, let's say, retail outlets or wholesalers. So maybe take the Walmart example. In that case, you may have a consortium, and that's going to have security measures just like any other shared computing resource that's going to have identification and authentication before you can get onto the network, and that may include the same kinds of mechanisms that you would use in any other computing environment. The consortium in that case is going to say, this is simply a computational resource for these 15 companies. They're the ones who can participate. They're the ones that we're going to give access credentials to. They're the ones whose computers are going to have the certificates that are necessary to do automated connections. So it really depends on the design of the blockchain. If you're looking at a truly public application, then you wouldn't have any of that, because in that case, you don't need to know who you're dealing with. You just need to know that the transactions themselves are reliable. And the blockchain itself, the consensus mechanism, is going to ensure that nothing gets added to that chain without agreement by enough of the participants who would have something to lose by saying anything other than the truth, that a new transaction is legitimate.
Great, thanks, Doug. Cynthia also was asking, what is the difference between POW and POS? How do they impact performance on a blockchain?
I'm not sure that either Andrew or I are total experts on this, but I'll give it a shot. POW is proof of work, which is the basic approach that has been used on Bitcoin and most of the other public blockchains to date. Proof of work basically says that nothing gets added to the blockchain unless there's proof that somebody has done enough work to validate that this is a good new transaction, and it can't be added easily. The computational problems of adding a block in Bitcoin or Ethereum, for example, it requires a great deal of computational power to test different scenarios to find the one that actually solves the problem. And that's what takes so much electricity. That's why you have so many different participants, miners as they're called, trying to work to add the new block and earn the reward for adding that block. So it is computationally very, very expensive, and the work is the work that's done to actually solve that cryptographic problem. Proof of stake works a bit differently, and this is the technology that is expected to become more dominant in public blockchains over a period of time, where the players basically create bets that have, I say the players, I mean the miners that are trying to add a block. They basically have bets that if they win, they will get a small reward, and if they cheat, they will be found out and they will lose. And they have, therefore, enough stake in the game. They have put enough bet down on playing honestly that it's actually not in their economic interest to cheat. And that's basically the way the proof of stake approach works. And I'm vastly oversimplifying, so those who know that, I would just ask your forbearance, but that's really the upshot is that you have too much to lose to cheat because of the way the stakes are set. You have to bet a certain amount, and you stand to lose it if you cheat.
It sounds like that's a great explanation, Doug. Whether you're an expert or not, certainly is a good analogy for the difference of proof of work and proof of stake. So thank you for that. Gaj was asking, he's interested in looking at ways blockchain could disrupt existing ways of interaction between industries. So payment gateways with reservations or travel ancillaries with a common guest profile. Today, these are disjointed and demand agreements. How will blockchain disrupt the agreements required to work in between these intermediaries, given it has a potential to eliminate middlemen?
I think that's a great question, but very much nuanced because I thought the direction was going to be going in how does the transaction, how does the data get flow between one entity and another. But actually, at the end there, the curveball was the question about how can it serve to level the playing field, if you like, between the different entities. But I do think there are two parts to that question. Of course, blockchain by itself is not going to magically create or solve a problem. Is not going to magically solve this issue. There has to be a will, and I would give an example of the loyalty programs. There are companies out there that are operating on the blockchain right now and launching products on blockchain that facilitate interoperability between loyalty points. And there's nothing magical about this in particular because they've still had to go to the loyalty providers to get agreement between how data is going to be exchanged and how loyalty points will be leveled between each of the programs. So I don't think blockchain is a panacea to solve that problem of getting agreements between the entities, which is the second part of the question. But I think as we've been able to establish, hopefully it would be able to provide the level of transparency to make the transactions more open.
Great. Thanks for that answer, Andrew. Great answer. So one other question that I know I often think about is where is all of this data stored? It just seems like if everybody has access to this blockchain and they're all able to add data, where does it all go? Where does it live?
Well, it depends if it's a public or private blockchain or consortium. If it's a public blockchain, it's living on the computers that are run by the miners who have chosen to invest their time. And really anybody can do that. I actually know of a hotel in France that has Bitcoin mining machines that it is using to heat its conference room. It produces enough energy, and all they had to do was go out and buy the machines and download the free software, and they were up and running, and they were miners. And probably every once in a while they earn a mining fee from actually creating the next block on the Bitcoin chain. And each each miner has a complete copy of that particular blockchain. And the sizes are not so large that you can't fit them generally on most PCs. Now, if it's private blockchain or consortium blockchain, then it's really up to whoever created it to decide how many copies are there, where are they, but the technology itself can be run on a single computer or 5 or 10, or how much redundancy do you want? And the upshot is, for the public blockchains, you can stage your own mining machine and you'll have a whole copy of Bitcoin or Ethereum or whichever public blockchain you're working with.
All right. Great explanation again. Thanks, Doug. All right, if there are no other questions, oh, we have one more. So how can blockchain bridge the gap between travel and hospitality industry? Starting from booking your travel tickets, planning your trip in the city, hotel and restaurant checks, and more.
Yeah, that's an interesting question, and I'm tempted to suggest that the document that we put up from the World Economic Forum, the Digital Traveler Program, really addresses a large part of that, because it basically says there's an ecosystem, and it's still conceptual at this point. This isn't something that exists, but it's getting very serious interest by some of the exact types of companies you're talking about. It's basically tying together the entire traveler experience around a digital identity that the guests themselves potentially creates and then shares with the different suppliers or governments in cases of visas or passports, security agencies in the case of airport security, airlines, rental car companies, hotels, and potentially restaurants, theme parks, you name it. It really is about tying together the customer experience around a blockchain that is centered on the person. And that's certainly something that's been talked about in the pre-blockchain world. What's interesting about blockchain is it actually has the building blocks that could enable that to be done in a world where, quite honestly, not everybody trusts everybody else. The reason we have intermediaries is that many people don't trust different travel suppliers or other hospitality providers to deliver exactly what they say they're going to. And the intermediaries are often a way to gain trust in that process. If the trust is built into the blockchain, then that could potentially change. So I would say that the best answer to that question would be to go read that document. It's actually one of the most interesting things I've probably read in the travel industry in the last 10 years. I'll put that link back up on the screen just briefly before we break.
Yes, thank you, Doug. And something that we can maybe provide some access to through links in our blockchain work group. So if you're involved in the blockchain work group, you have access to some of those resources. And if I don't recall if we put that in the blockchain white paper, which is available on our website under standards and resources. There may also be some additional resource links, such as the World Economic Forum's paper. So I think that is all of our questions at this time. So I want to thank everyone for joining us today. And if you enjoyed this webinar, we would love to hear your feedback. And if you want to share this with anyone else, it will be made available on our website in the next week or so. So again, thank you all for joining.